the Uniform Relative Force Model, URF. The uniform relative force is a key conceptual framework within the theory of relative gravity. It serves as an abstract model to describe how particles, matter, and even galaxies are held together within the fabric of space-time. The idea behind URF is to find a common, unified force that connects the different aspects of gravity, electromagnetism, and the nuclear forces, strong and weak, offering a way to describe how these forces can exist in relation to one another. Conceptualizing uniform relative force. The uniform relative force, URF, is conceptualized as a manifold where different forces, electromagnetic, gravitational, strong, and weak, can be understood as part of the same spectrum of forces, differentiated only by their context in space-time. Just as particles, matter, and galaxies are held together by an invisible force, the model imagines the forces acting on different scales, whether atomic or galactic, through a shared property of relative force that links them. This creates a consistent framework for understanding the interplay between different types of forces. In this framework, URF could also be compared to a voltage in a way analogous to the principles of Ohm's law from electrical theory, which relates voltage, current, and impedance. By this analogy, URF represents the potential force acting on a system. It is not a single uniform value, but rather varies depending on the context, such as the scale or reference frame of a given interaction. Analogies with Ohm's law. Just as Ohm's law describes how electrical impedance affects the relationship between voltage and current, the concept of URF applies a similar logic to how different forms of matter and energy interact within the universe. Impedance here could be seen as the contextual resistance that governs how forces act upon different bodies, particles, atoms, or galaxies. Voltage as URF. The voltage in this analogy represents the potential force within a system. In the context of relative gravity, this potential can manifest as gravity at the galactic scale, electromagnetism at the particle scale, or other forms of interaction at varying distances or energy levels. Just as a higher voltage can drive a more dispersed current, different forces, like gravity or electromagnetism, can be understood as manifestations of URF, depending on the scale and context. For example, in dark matter, URF could explain its effect on cosmic structures and galaxies, despite it being undetectable through traditional means, i.e., electromagnetic radiation. Even though dark matter does not directly emit or reflect light, it still plays a crucial role in gravitational forces on the cosmic scale. In this way, URF provides a framework for understanding dark matter and spatial bodies as equivalents in the broader model of relative mass. Contextual differences, current and impedance. In electrical circuits, voltage is related to current and impedance. By analogy, URF's role can be viewed as representing a unified force that, depending on the context of the system's impedance, e.g., the specific conditions of a gravitational field, electromagnetic environment, or nuclear interaction, determines how it manifests across different scales. For instance, in gravity, the impedance might represent the curvature of space-time around a massive object, whereas in electromagnetism, it might correspond to the medium through which the electric and magnetic fields propagate, such as a vacuum or a conductive material. Thus, while URF itself is constant as a force across these contexts, the way it is expressed can differ based on the impedance or resistance to force propagation inherent in the environment. The unification of the four forces. The uniform relative force, URF, model provides a potential pathway to unify the four fundamental forces of nature: gravity, electromagnetism, and the strong and weak nuclear forces. According to this model, these forces, while distinct in their individual properties, share a fundamental symmetry when viewed through the lens of spatial time. This means that they can all be understood as different expressions of the same underlying force, with the distinction between them arising from their context in space and time and their respective impedances or resistance to transmission. Electromagnetic force acts between charged particles and is mediated by photons. It governs interactions between atoms and molecules, shaping the structure of matter. Gravitational force acts between masses and is mediated by gravitons in the context of quantum gravity. It shapes the structure of large-scale objects like planets, stars, and galaxies. Strong nuclear force acts within atomic nuclei, holding protons and neutrons together, and is mediated by gluons. Weak nuclear force, responsible for radioactive decay and other subatomic processes, mediated by W and Z bosons. Each of these forces, under the uniform relative force model, can be seen as a unique manifestation of the same relative force, which, depending on its specific context, will behave differently. However, the model suggests that at a deeper, unified level, they are interconnected and share an intrinsic symmetry that ties them together within the structure of the universe. Dark matter and spatial bodies as equivalents. In this framework, dark matter can be viewed as an equivalent to ordinary matter in terms of relative mass, despite its lack of direct interaction with light. Just as electrical current and voltage are interdependent, dark matter and spatial bodies like galaxies can be seen as part of a larger dynamic system, both influenced by URF in different but related ways. The concept of URF thus provides a conceptual basis for understanding how dark matter, visible matter, and force interactions are interconnected, despite appearing different at first glance. This conceptual unification offers a pathway toward understanding the cosmic scale interactions of forces in a manner that may eventually help reconcile different forces within a single theoretical framework. Conclusion. The uniform relative force, URF model, suggests that the four fundamental forces, gravity, electromagnetism, and the strong and weak nuclear forces, can be understood as different expressions of the same underlying force, depending on the context of the system in which they operate. By relating these forces to concepts from electrical theory, such as voltage, current, and impedance, the URF framework offers a unified view of how forces interact across the universe, from the smallest particles to the largest cosmic structures, all held together by the shared property of relative force.